Homework 4.3, Properties of Logarithms, Video 4. Homework due Friday, May 29th at 11:59 p.m. The following video is directly associated with questions 7 through 9 on your homework and is also incorporated in questions 10 through 19. You'll notice we've got the product and quotient rule summarized here, but there's one more rule that we're going to see now and one more at the end of this video series. The next rule we're going to see is the power rule. And just like the product and the quotient rules, there are calculus versions. So there's a calculus version of the power rule. So to be more descriptive, we could call it the power rule for logarithms. The power rule is a rule for what you can do for any logarithm with any permissible base b, whose argument, which we'll call m, has a power on it. Let's put a p on it for power. Now, you might be thinking, we've seen a property like this already. In fact, you wrote it on the first video. I believe the one I wrote on the first video looks something like this. Because this is the power that turns the base into the argument. But do you see the main difference between this property, at least the logarithm on it, and the one we're about to build? They both have powers. I'm using different letters for them, but that's irrelevant. But there is a structural difference that makes all the difference in the world. Structurally, this logarithm, the log has the same base as the argument. The base inside the argument is b, the base of the logarithm is b. But for the power rule, that's not required. That's why these are two different letters. If they matched, then it would just be that rule. So think of the power rule as a more general version of what to do with a log that looks like this without the requirement that these numbers match. The power rule is ridiculously easy to execute. The power rule basically says if there is a power on the entire argument, you may remove the power and put it in front of the logarithm as a factor. So you can put the power in front and multiply. Everything else stays the same. This is a pretty important and, dare I say, powerful rule because it allows us to do two things that we usually don't get to do anywhere in math. Thing number one, freely move something inside of an argument and outside of an argument. P's on the inside, P's on the outside. And secondly, take something that's in an exponent and drag it down to the ground with everybody else. That second part's going to be really important in the next homework assignment. All right, so all we have to do is look for a power and put it in front as long as the power belongs to the entire argument. So for example, we have log base p of x to the third power. There is a power that belongs to the whole argument. The power rule simply says we can pull the 3 down. All right, 3 times log base p of x. That wasn't difficult. But the second one doesn't have a power. It has a 4th root. So can we apply the power rule when there's not a power? Well, no, we can't. But the follow-up question is, can we rewrite it so it does have a power? And the answer is, of course we can. Otherwise, I wouldn't have it sitting here. There was an exponent rule that said b to the, and I forget the letters I used, but it really doesn't matter, b to the x over y power is the y-th root of b to the x. In other words, the numerator was actually a power, whereas the denominator was the index of a radical. I currently have a radical. I need to think of it as a power. And by the way, I think I've said this before, but for those of you heading towards calculus, you have to be able to go between these two fluidly and seamlessly without even thinking twice. Because when you do calculus, the rules for calculus are based on powers. So anything that's a radical has to be turned into a power first. But for this one, if we want to view the radical as a power, what power would we put on the w? Well, in order to answer that, I need to know 2 questions. Question number 1, what power is currently on the W? Inside the radical, right here. You don't see one, do you? Because it's an implied one. Whatever the power is actually the numerator. And the other question is, what's the index on the radical? What's the number in this little nook for? That becomes the denominator. And now the argument has a power on it. So now the power rule can be applied. Bring the power down in front, so 1/4 times. And frankly, you don't have to put the multiplication dot, it's just for emphasis. Log base 3. The W is still in the argument, it's only its power that got removed. So the power rule, as you can tell, is actually pretty straightforward. There's not a whole lot of hoopla to it. I think the trickiest part is when your argument is inside of a radical and you have to use that exponent rule to rewrite it as a rational exponent.